Okay, classmates. Actually, not classmates. My students. That's you. Hello. It's Mr. Lee here. Trying to show you that little computer program whiz thing to show you the ratios for the quadrantal angles. So I thought I'd try to show that to you now. I hope you have your notes in front of you. In the notes, remember I had sine, cosine, and tangent and asked you to define them the following way. Sine theta is now defined as y over r. The y coordinate divided by r, and r of course is I call it the radius because this is moving and it makes a circle. You can also call it the length of the terminal arm. Okay. Cosine of course is defined as x over r, and tangent is defined as y over x. So in that table we looked at these quadrantal angles, and the first one is actually theta equals to 0. So let me move it to 0 and let's see what happens. Okay. Remember, we're looking for the triangle, but you really can't see a triangle at theta equals to 0. However, we do have the coordinates, and notice here we have x equals to 1 and y equals to 0. And of course we always define r to be equal to 1. So using those three pieces of information, we can now describe and calculate the trig ratios for sine of 0, cosine of 0, and tangent of 0. Sine of 0, as defined as y over r, just becomes 0 divided by 1, which is 0. Notice down here cosine of 0 is defined as x over r, so the x value is 1. R is 1, so therefore cosine of 0 equals to 1. And tangent of 0, well, that's defined as y over x, and so y is 0, x is 1, so 0 divided by 1 is just 0. So here are the pictures that relate to the 0-degree angle in the table. Okay, so I'm going to now move this terminal arm. I'm going to move it to 30 degrees so we can double check to see if this makes sense with what I taught you last day with those special angles. Here's, that's 29, I want 30. I'm nervous. I can't get this there. 30, okay, there we go. See, that's 30. So really, you gotta imagine this point here in green having a coordinate. Now, look at the x value. It's a little bit less than 1. So much less that the computer says it's 0.8660. That's my phone ringing. Okay. And then we've got here the y value, which is 0.5, so it's about halfway between 0 and 1. And once again, the r value is just 1. Okay. So, taking a look at sine 30, we have y, which is 0.5, divided by r, which is 1. So we have 0.5. And then there's cosine of 30, which is the x value, that's 0.8660, divided by 1, which kind of makes sense, right? There's 0.8660. And if you remember, that's the same thing as root 3 over 2. Go to your calculator, punch in root 3 over 2, and you should get 0.8660. And there's also tangent 30, which is just y over x, so 0.5 divided by 0.866 is this decimal, 0.5774. And that's the same thing as 1 divided by root 3. So I think everything holds for 30 degrees. Okay, I'll move to 45. There's 45. And you can look at those ratios, and those ratios will be the same, okay, as what we had in the special angle table. 0.7071 is just 1 over root 2. Okay. And then I can continue on to 60 degrees for the other special triangle. Okay, there you go. There's 60. And you can look at those numbers. By the way, the last one here, 1.732, that's the same thing as root 3. And then now let's continue on with those quadrantal angles. So let's go to 90. Here is 90. So notice the coordinate for x is 0, the coordinate for y is 1, and once again r is always 1 in this case, so sine of 90 is just 1 over 1, cosine of 90 is 0, tangent 90 is 1 over 0, which of course is undefined. Okay. Let's continue on to the next quadrantal angle, which is 180. You can also see how the actual y values and x values change. Okay, here we go. -1 and 0 is my new coordinate at 180 degrees. X is -1, y is 0. Plug it into the trig ratios again, and you'll get the actual ratio for sine 80 being 0, cosine 180 being -1, and tangent 180 being 0. Okay, let's scoot on down to 270 degrees, and look now. Notice my y values are negative. Why? Because I'm below the x-axis. Okay, my x values are still negative right now. Why? Because they are to the left of the y-axis. And here we go at 270 right there. We've got the value of x being equal to 0 and y being equal to -1. We'll plug it back into the formulas for sine, which is y over r, cosine x over r, tangent y over x, and there you have it, the values of -1, 0, and once again undefined because we're dividing by 0. And of course I can continue to scoot on back up to 0 degrees or 360, and notice once again now my x values are now positive, but my y value is still negative until I return to the initial arm.